methods used to assemble simple fitting components together. Additionally, we will see which factors can cause assembly failures. In machine shop assembly, various methods are used for securing components together. A few of the common methods are doweling. This is used for accurate positioning of two or more parts. This allows the parts to be separated and relocated in position. Different types of dowels are used depending on the type of assembly. The components doweled are always fixed with retaining screws in the assembly. Pinning. This is also a method of locating and securing components together. Pins are of different types. Parallel pins. These are fitted like dowels in reamed holes and held in position by a retaining ring. Taper pins can be dismantled easily and assembled without any change in location. The holes for fitting taper pins are finished using taper pin reamers. Spring pins. This eliminates the need for drilling and reaming of the assembly together. Peening. When parts are to be assembled, this is one method of assembly. This is similar to riveting. Brazing. This is a process of joining metals by using layer of non-ferrous metal between the surface to be joined. The alloy used for brazing is known as spelter, combination of copper and zinc. Using of adhesives. The adhesives commonly used are epoxy adhesives. This adhesive gives a strong bond between materials to be assembled. Possible causes of assembly failures. Poor assembling. Errors in assembly can result from various causes such as ambiguous, insufficient or inappropriate assembly procedures, misalignment, poor workmanship and inadvertent errors performed by workers during assembly. Example: failure of nut and stud assembly by fatigue can occur if any sort of loosening of nut subjected to external load happens under such conditions. Therefore, it is essential to have proper information regarding the sequence of tightening the nuts and torque to be used for tightening purposes. Poor service conditions. Failure of engineering components can occur due to abnormal service conditions such as exposure to high rate of loading, unfavorable environment and high or low temperature conditions. These conditions can cause oxidative, corrosive and erosive damage to the component which it may not be designed to withstand. Investigation of the design, manufacturing process and material compatibility is essential to establish the contribution of abnormal service conditions to the failure. Therefore, the failure of an engineering component is a complex phenomenon that requires a thorough investigation. Weight of raw material. Calculate theoretically weight of material. Calculate volume of material and multiply with density of material. It gives you the exact weight of raw material required. While calculating weight, do not consider final dimension, always consider plus size for machining and other operation. Cost of operation. Decide each operation to be performed on flanges like drilling, machining and boring. While selecting the process, do take care of sequence of operation as it matters a lot on costing. You need to allot time required for a particular operation, considering all factors of machine. On their basis of price of machine, depreciation, and cost of electricity consumed, you need to finalize cost of machine running per hour. Now multiply time required for a particular operation and machine running cost per hour. Procedure to assemble fitting using dowel pins and cap screw assembly using torque wrench. Check the raw materials size. File part 1, 2 and 3 to overall size maintaining parallelism and perpendicularity. Check the flatness and squareness with tri-square and dimensions with vernier caliper. Apply marking media on part 1 and 3 and mark the dimensional lines as per drawing. Punch witness mark and drill hole marks. Chain drill, cut and remove the excess metal on part 1 and file to size. Similarly, chain drill, cut and remove the excess metal in part 3 and file to size and shape. Fit part 2 in part 1 and 3, maintaining tolerance plus or minus 0.04 mm. Assemble part 1, 2 and 3 all together and clamp it using parallel clamps maintaining squareness. Hold the assembly setting in drilling machine table along with suitable fixtures. Drill, countersink and ream the hole as per drawing and fix diameter 5 mm dowel pin without disturbing the assembly setting. Similarly, drill, countersink and ream the other dowel pin hole without disturbing the assembly setting and fix other 5 mm diameter dowel pin. Drill holes for tapping in part 1 and 3 without disturbing the assembly setting. Separate the assembly setting, drill diameter 6.6 mm through hole and diameter 11 mm counter bore to the depth of 8 mm in part 3 to enter the cap head screws. Hold part 1 in benchwise and cut M6 internal thread in 2 holes to fix cap head screws. Clean the threads without burrs. Finish file in part 1, 2, 3 and deburr in all corners of the job. Reassemble part 1 and 3 along with dowel pins and cap screws. Fix the cap screws. Fit part 2 in part 1 and 3 opening slot. Apply a little oil and preserve it for evaluation. Procedure to fix dowel pins. Keep position 1 and position 2. Tighten the socket head screw such that there is a gap of 1 pitch of the socket head screw. Drive the dowel using a hammer such that about 5 mm of the chamfer side of the dowel enters into the reamed hole. Check for the perpendicularity. Drive the dowel into the reamed hole such that chamfered end of the dowel enters fully into the position 1 as shown. Drive the dowel keeping pin punch diameter 5.8 over the radius of the end of the dowel such that the chamfered end of the dowel enters into position 2. Drive the dowel in about 10 mm into position 2. Tighten the socket head screw such that there is no gap. In this video, we learnt about various techniques to secure components together, possible causes of assembly failures and how to rectify them, procedure to assemble simple fitting using dowel pins and cap screw assembly using torque wrench. Thank you for watching. Hello everyone, welcome to this video of Power Tools, Practice Operation of Power Tool for Fastening. In this video, we will learn about power tools, their types and to maintain these power tools in proper shape. Torque is the application of a force acting at a radial distance and tending to cause rotation. Torque is used to create tension in thread fasteners. When the nut and bolt are tightened, the two plates are clamped together. The thread converts the applied torque into tension in the bolt shank. This turn is converted into clamping force. The amount of tension created in the bolt is critical. What does power tools mean? Power tool is a device that is activated by a power source apart from manual labor. There are various types of power tools, for example, electric screwdriver, hammer drills, and fast screw guns. The tools are used in construction and several do-it-yourself jobs such as productions, assembly, packaging, and maintenance. They are available in multiple sizes and shapes and are simple to operate. Every reliable manufacturer makes sure that their power tools are marked under the rules and regulations of Occupational Safety and Health Administration or OSHA standards. Power wrench. A power wrench is a type of wrench that is powered by other means than human force. A typical power source is compressed air. There are two main types of power wrenches. Air ratchet wrench. An air ratchet wrench is very similar to hand-powered ratchet wrenches in that it has the same square drive but an air motor is attached to turn the socket drive. Pulling the trigger activates the motor which turns the socket drive. A switch is provided to change the direction of socket drive. This type of power wrench is designed more for speed and less for torque. If high levels of torque are desired, an impact wrench should be used. Pneumatic torque wrench. A pneumatic torque wrench is a primary torque multiplier or a gearbox that is mated to a pneumatic air motor. At the end of the gearbox, there is a reaction device that is used to absorb the torque and allows the tool operator to use it with very little effort. The torque output is adjusted by controlling the air pressure. These planetary torque multiplier gearboxes have multiplication ratios up to 125:1 and are primarily used anywhere accurate torque is required on a nut and bolt or where a stubborn nut needs to be removed. The pneumatic torque wrench is sometimes confused with a standard impact wrench due to their similar appearance. A pneumatic torque wrench is driven by continuous gearing and not by the hammers of an impacting wrench. A pneumatic torque wrench has very little vibration and excellent repeatability and accuracy. Torque capabilities of pneumatic torque wrenches range from 118 Nm up to a maximum of 47,600 Nm. Torque wrench for fastener tightening. A tool for setting and adjusting the tightness of nuts and bolts to a desired value is called torque wrench. Always use a torque wrench to tighten fasteners and use a slow, smooth, even pull on the wrench. When reading a bar-type torque wrench, look straight down at the scale, as viewing from an angle can give a false reading. Only pull on the handle of the torque wrench and do not allow the beam of the wrench to touch anything. Power screwdriver. A power screwdriver will merely give us a screw driving capability at a quick and efficient manner. They are designed to work at a slower rate than typical power drills. They, however, have more drill torque, giving us the ability for more power, such as drilling screws into materials without having to do any pre-drilling. Solid models will give us torque limiters and allow you to set the maximum torque to save the head of the screw or any mishaps of snapping. They can also help in hard-to-reach spots and corners, since they are usually smaller than drills and only take one hand. Maintenance of power tools. Properly storing power tools, performing maintenance as needed, and replacing machine parts will extend a tool's life to its full potential and deliver more value to its owner. Our 3 guidelines for tool storage are: store tools in an area protected from the elements like moisture. Store tools in a clean and organized space. Store tools in a well-ventilated area. Before being stored, most power tools can use a little cleaning and a couple of quick checks for damage or other problems. Here's some maintenance tips for keeping those tools in good shape. Use a toothbrush and a soft cloth to wipe debris from power tool casings before storage. If available, use an air compressor to clean out power tool vents. Lubricate power tool parts that need to be lubricated. Following instructions in the tool's user manual will be help here. Check the parts that hold a tool together, screws and other fasteners. Tighten up anything that might have been shaken loose during operation. Electrical cords should be checked with each use of a power tool. A bad power cord can be dangerous and should be replaced before the tool is used again. Keep blades and other cutting accessories sharp. Check bits and other accessories for wear and damage. To practice operation of power tools for fastening, identify the power tools, follow the work operations required for the use of hand and power tools, identify the source and access of power supply to power tools, select the proper safety equipment such as safety goggles, hand gloves, boots, apron, etc. and wear them. Check the tools for serviceability and safety, and if there are any faults, report the same to the concerned authority. Select and use the equipment to hold and support the power tools. Choose the sequence of operations to produce the desired outcome from power tools. Select the tool required for operation and fix it according to need. Power tools should be cleaned and stored safely in appropriate location according to standard workshop procedure and manufacturer recommendations. Fasten the nut and bolt. Clean the power tool and keep it in a safe place. Keep work area neat and clean.
In this video, we learnt about concept of torque, power tools and the types, maintenance of power tools, practicing the use of power tools. Thank you for watching. Hello everyone. Welcome to this video of tightening of bolt or screw with specified torque. In this video, we will learn about the need for different types of fasteners used in various operations and the procedure to tighten these fasteners using the air impact wrench.
Need for fasteners. In the industrial field, much depends on the proper choice of fasteners to be used in each job because poorly selected fasteners might greatly lead to unsafe condition. It may increase the assembly cost. Quality of the product may get degraded or compromised. Let us now learn about threaded fasteners. Fasteners that fall into this category utilize the wedging action of screw thread for clamping pressures. To achieve maximum strength, a threaded fastener should screw into its mating part by a distance equal to 1.5 times minimum the diameter of the thread. Machine screws. Machine screws are used for general assembly work. These are manufactured in both coarse and fine series and fitted with either a slotted or recessed head. Sizes vary in diameter from 1.5 mm to 12 mm and in length 2 mm to 75 mm. Machine bolts. Machine bolts are manufactured with square and hexagonal heads. They are used where a close tolerance assembly is not required. Available in diameter 6 mm to 75 mm and in length 12 mm to 300 mm. Tightening the nut on machine bolt produces clamping action. Cap screws. Cap screws are used when assembly requires a stronger, more precise and better appearing fastener. A cap screw is fitted through a clearance hole in one of the piece and screws into a threaded hole. A clamping action is developed by tightening the cap screws. Cap screws are manufactured to closer tolerance than machine bolts and produced with semi-finished bearing surface. They stocked in aluminium, brass, bronze, mild steel, alloy steel, heat-treated, stainless steel and titanium and in coarse, in fine and special thread series. Cap screws are available in diameter from 6 mm to 50 mm and in length from 10 mm to 200 mm. Nuts are not included with cap screws. Set screws. Set screws are used to prevent pulleys from slipping on shafts, positioning and holding collars in place on shafts and holding shafts in place in assemblies. Headless set screws have either a slotted or socket head and threaded entire length. Uses of headless set screw with various styles of screw points. Flat point set screw is used on parts requiring frequent adjustment. Oval point set screw is used against a shaft that has been spotted to receive it. Cone point set screw is used for setting machine parts permanently on shaft and it is used as a pivot or hanger and for adjustment. The half dog point set screws are probably one of the most useful and it can be used as a dowel. A hole is drilled to receive the point. The full dog point set screw is suitable for use as a key that slides in a keyway. Let us now understand about the different types of screws. Self-tapping screw. To eliminate the cost of tapping, a thread-forming screw has been derived. These are designed to form a thread as they are driven. Thread-cutting screws. Thread-cutting screws which are hardened, cut rather than form threads. Type F cuts a standard machine thread used in castings and forgings. Type BF. This screw is recommended for die castings and plastics. Type L, widely used with plastics. Driver screws. Driver screws are simply hammered into a drilled hole or punched hole of the proper size. They make a permanent joint. Stud bolts. Stud bolts are threaded on both ends. One threaded end is designated for semi-permanent installation in a tapped hole, while the other end threaded for standard nut assembly to clamp the pieces together. Nuts. Nuts utilize a hexagonal or square head and are used with bolts with the same head shapes. They are available in various finish. Regular nut is unfinished, not machined, except on the thread. Regular semi-finished is machined on the bearing face to provide a truer surface for the washers. Heavy semi-finished are identical in finish to the regular semi-finished nut, however the body is thicker for additional strength. The jam nut or check nut is used where the strength of the full nut is not needed. They are frequently used in pairs or with standard nuts to prevent accidental unscrewing of the first nut. Castle and slotted nut have milled slots across the flats, so that can be locked with a cotter pin or split pin or safety wire that is inserted through the slot and a hole drilled in the bolt to prevent the nut from turning loose. A corn nut or cap nut are used when appearance is of primary importance or where projecting threads must be protected. They are available in low or high crown styles. The wing nut is used for parts that are frequently disassembled and reassembled. It can be loosened or tightened rapidly without the need of a wrench. Nuts are manufactured in the same material as the bolts. To tighten bolt or screw with specified torque. Select a proper power tool for fastening. Select an impact wrench power tool operated by compressed air for tightening and loosening nuts. Check the air impact wrench is connected to the air line. Select correct size of socket which can withstand sudden impact force. Select 6-point impact socket. Fit the socket on the air impact wrench. Set the direction of spin forward or backward with the help of wrench lever. Set the torque by turning the valve to increase or decrease. Insert the impact socket on the wheel leg nut. Trigger the switch of the impact wrench to loosen and remove the nut.
In this video, we learnt the need for fasteners in assembling components, types of threaded fasteners and screws, procedure to tighten bolt or screw with specific torque. Thank you for watching.
Selection of right tool as for tightening or loosening of screw or bolt as per accessibility.
Tightening or loosening a screw or bolt can be easy or hard depending on the accessibility of the screw or bolt, the type of screw or bolt, the size of the screw or bolt, and the material it is made of. If accessing the screw or bolt is difficult, then it might take longer than expected to tighten or loosen it. Power tools are designed to perform tasks more quickly and efficiently than traditional hand tools, saving time and effort. In this video, we are going to learn about the selection of right tools for tightening or loosening of screw or bolt as per accessibility. Come, let's go into the video.
At the end of this demonstration, you will be able to learn about all the tightening tools. Record the tools required for the following applications. Select the right tool for tightening and loosening of screw or bolt. Tools required: pneumatic screwdriver, twin motor nut runner, angle nut runner, battery screwdriver, nut runner. Now we are going to go through all the tools that are used for tightening and loosening of screw or bolt. There are a lot of tools used for tightening and loosening of screwdriver. The most commonly used tools are pneumatic screwdriver, twin motor nut runner, angle nut runner, battery screwdriver and nut runner, impact wrench or nut runner. The first tool we are going to learn about is pneumatic screwdriver. This type of screwdriver is powered by air, making it much more lightweight and easy to maneuver than a traditional electric screwdriver. Pneumatic screwdrivers also have less vibration than electric screwdrivers, making them ideal for delicate projects. In addition, pneumatic drivers are powered by air compressors. The compressor does not need to be continually connected to the driver. It can run independently of the tool, so there is no loss of power when switching between tools or during operation. One of the greatest benefits of a pneumatic screwdriver is that it's lightweight and is small in size. This allows users to easily maneuver their way around tight corners and delicate parts while still having enough force behind their actions. A traditional electric screwdriver has much more weight than a pneumatic driver and is much harder to maneuver. The small size of the pneumatic driver allows for easy storage as well, which is a huge benefit for anyone with limited space in their workshop or garage. The second tool we are going to discuss is twin motor nut runner. If you're looking for a powerful and versatile nut runner, twin motors is a great option. The nut runner features two motors that allow it to handle a variety of different applications. Plus, its compact size makes it easy to use in tight spaces. This product can be used on everything from bolts and screws to nails and studs. Its sharp blades make quick work of any material, while its dual motors provide the power you need to tackle even the toughest tasks. Here are some other features. Compact size allows it to fit easily into tight spaces. Two powerful motors ensure smooth operation even when working with tough materials. Sharp blades allow for quick and easy cutting of bolts, screws and nails without damaging the surrounding area. Comes with a 360-degree swivel head that allows you to easily rotate your device as needed. Angle nut runner. The angle nut runner is perfect for repairing or building anything in your workshop. You'll be able to tighten and loosen bolts of all sizes with ease. Whether you're working on vehicles, appliances, or even furniture, this tool will make the job quick and easy. It's also great for tightening nuts and bolts in difficult-to-reach areas like under the hood of your car or behind the refrigerator. Battery screwdriver and nut runner. There are two types of tools that can help you with the task of tightening and loosening nuts. These are nut runners and battery-powered screwdrivers. Both tools have their positives and negatives, but both will get the job done. It has an adjustable handle that allows for easy access to tight spaces. It can be used on a variety of nuts and bolts up to 3-4 inch in diameter. It comes with a ratchet head that makes it easier to tighten or loosen bolts. The head is also reversible, which means you have the option of using it as either a nut runner or a screwdriver. It is lightweight, making it easier to carry around and use. Battery screwdriver comes with an adjustable speed that allows you to control how fast or slow the head rotates. It has a wide range of uses other than just tightening and loosening nuts. This includes drilling, driving screws, and unscrewing bolts. You can use rechargeable batteries to power this tool, so there is no need for electricity. Now, let's have a look at what tools is to be used for the mentioned applications. Impact wrench. Loosening and tightening of large dimension bolts during maintenance. High torques with moderate accuracy requirements. Assembly of machine screws at low torque and medium to high accuracy. Application where the counting of properly tightened screws in a joint is essential for product quality control. Battery screwdriver. Small screw assembly at low torque and medium-high accuracy. For maximum mobility and where the air hose or electric cable would limit access or pose a safety risk from a jammed cable. Pneumatic screwdriver. Assembly of machines screws where speed and handiness are important. Medium accuracy. Nut runner. Assembly of machine screws and nuts where accuracy requirements are high. Bolts with limited accessibility. Angle nut runner. Assembly of machine screws where in the tightening process the torque and/or angle must be monitored for quality control and certification. Assembly where in the tightening process control to a high level of accuracy is necessary. Twin motor nut runner. Applications where articulated arms are used to support the reaction torque for multiple spindle tightening and for automatic systems.
Let's have a recap of what we have learned today. We have learned to learn about all the tightening tools, record the tools required for the following applications, select right tool for tightening and loosening the screw or bolt. Thus, we have learned about selection of right tools as for tightening or loosening of screw or bolt as per accessibility. Do this exercise with the help of your instructor.
Assembly sliding for using keys, dowel pin and screw, plus or minus 0.02 mm accuracy on plain surface, and testing of sliding fitting jaw.
In this video, we will be discussing about the assembly sliding for using keys, dowel pin and screw plus or minus 0.02 mm accuracy on plain surface and testing of sliding fitting job. This is a critical process in many industries and it is important to ensure that the accuracy is maintained in order to produce quality products. Come, let's go into the video.
At the end of this demonstration, you will be able to mark dimensions with vernier height gauge, file part 1, 2, 3, 4 to size, drill, ream and tap at correct location, count a bore to the required depth, assemble part 1, 2, 2, 3, 4 with dowel pins and cheese head screws. Tools required: steel rule 300 mm. A steel rule is a measuring instrument that is used to take accurate measurements of the length, width, and thickness of various components. Scriber. A scriber is a marking tool that is used to make accurate lines on metal surfaces. Punch. A punch is a marking tool that is used to create indentations and other markings on metal surfaces. Ball peen hammer. A ball peen hammer is used to shape and form metal components, such as by bending or flattening a piece of metal or by shaping it into a specific form or contour. Hacksaw frame with blade. A hacksaw frame is used along with a blade to cut metals of different sections and is specified by the type and maximum length of the blade that can be fixed. Bastard file, flat. A bastard file is a type of file that has a coarse cutting surface, making it ideal for removing large amounts of material quickly from metal components. Smooth file, flat, square, triangle. A smooth file is a type of file that has a cutting surface that is much finer than rough or bastard files. It is used for fine shaping, smoothing, and finishing work on metal components after initial roughing out work has been done with coarser files. Flat files are typically used for removing material quickly and efficiently, creating flat or angled surfaces and shaping or smoothing curves or edges. The triangular shape of the file makes it ideal for reaching into tight corners and removing material from hard-to-reach areas. Triangle files are available in a variety of sizes and cuts, which determine the coarseness of the teeth on the file. Drill bits, required size. Drill bits are a common tool used by fitters for drilling holes into various materials such as metals. Reamers. A reamer typically has a cylindrical shape with multiple cutting edges that gradually increase in size from the tip of the tool to the base. The cutting edges are usually made of high-speed steel or carbide, which are highly resistant to wear and can produce a smooth and accurate surface finish. Tap set. The tabs in a tap set are designed to cut threads of specific sizes and shapes and are typically made of high-speed steel or carbide. Tabs are available in different shapes and sizes, including straight fluted tabs, spiral point tabs, and spiral flute tabs, among others. Counterbore tool. A counterbore tool typically consists of a shank and a cutting head. The cutting head may have one or more flutes and is designed to create a flat-bottomed hole with a large diameter than the drilled hole. Equipment required: surface plate or table. Surface plates are used to measure the flatness and precision of other components such as machine parts, tools, and fixtures. They are also used for layout and inspection work where precision and accuracy are critical. Vernier height gauge. A vernier height gauge, also known as a height gauge or a height caliper, is a precision measuring instrument used in metalworking and mechanical engineering to measure the height of objects, and also it's used to make precise marking on the jobs. Angle plate. An angle plate is a work-holding device used in metalworking and machining that is designed to hold and support work pieces at a precise angle to perform marking function using tools like vernier height gauge. Bench vise. A bench vise is a work-holding device that is mounted on a workbench or table and is used to hold a workpiece firmly in place during machining, cutting, filing, drilling, or other work. Vernier caliper. A vernier caliper is a precision measuring tool used in metalworking and mechanical engineering to measure the internal and external dimensions of objects as well as the depth and step measurements. Machines required. Bench drilling machine. A bench drilling machine typically consists of a base, a column, a table, and a spindle. The spindle is mounted vertically and is driven by an electric motor which rotates a cutting tool such as a drill bit. Pedestal grinding machine. A pedestal grinding machine, also known as a pedestal grinder, is a stationary machine tool used to shape and sharpen metalworking tools, drill bits, and other parts. Materials required. Mild steel flat, 65 × 10. MS flat or mild steel flat is a type of steel product that is flat in shape and has a rectangular cross-section. Dowel pin, diameter 6 to 20 mm. Dowel pins are small cylindrical rods that are used to hold two or more parts together in precise alignment. Cheesehead screw, M6, 20 mm. A cheesehead screw is a type of machine screw or bolt that has a cylindrical head with a flat top surface and rounded edges resembling a wheel of cheese. Key, 12 × 16 mm. Before starting job, there are some preliminary checks to be made. Those are as follows. The first check to be made is raw material check. Check the raw materials for its size. Next, we are going to file all the parts. File the parts 1 to its overall sizes, maintaining an accuracy plus or minus 0.02 mm with flatness and squareness. File the part 2 to its overall sizes, maintaining an accuracy plus or minus 0.02 mm with flatness and squareness. File the part 3 to its overall sizes, maintaining an accuracy plus or minus 0.02 mm with flatness and squareness. File the parts 4 to its overall sizes, maintaining an accuracy plus or minus 0.02 mm with flatness and squareness. Next, we are going to mark the dimension for making holes in all the parts. Mark the dimension and location of holes as per drawing on part 1 by using vernier height gauge. Mark the dimension and location of holes as per drawing on part 2 by using vernier height gauge. Mark the dimension and location of holes as per drawing on part 3 by using vernier height gauge. Now, we are going to punch witness marks in all the parts. Punch on the location of holes on part 1 using center punch. Punch on the location of holes on parts 2 using center punch. Punch on the location of holes on parts 3 using center punch. File the parts to its size and shape. Now, let's begin the process. Set all 4 pieces together and clamp them with parallel clamps and check the squareness by using tri-square. Hold all the pieces together along with clamps on a drilling machine table and center drill on part 2 and 3 in all hole locations. Remove the center drill from the drill chuck and fix diameter 5.8 mm twist drill and drill through hole on part 2 to fix dowel pin without disturbing the position of job. Ream the drilled hole with diameter 6 mm hand reamer with a tap wrench without disturbing the position of the job. Clean the reamed hole and fix diameter 6 mm dowel pin in the assembly. Similarly, drill other drill hole, ream and fix dowel pin in part 3 without disturbing the assembly. Fix diameter 5 mm twist drill and drill through hole on part 1 and 2 in assembly without disturbing the job to cut M6 internal thread in part 1 to fix cheese head screw. Fix diameter 5 mm twist drill and drill through hole on part 1 and 3 in assembly without disturbing the job to cut M6 internal thread in part 1 to fix cheese head screw. Similarly, drill diameter 5 mm drill through holes in part 1, 2 and 3 without disturbing the job to cut M6 internal thread in part 1. Disassemble the setting and separate the part 1, 2, 3 and 4 of job pieces. Fix counter bore tool in drilling machine spindle and counter bore in part 2 and 3 to fix M6 cheese head screw. Fix countersink tool and chamfer both ends of internal thread, cutting holes 1 mm into 45 degree in part 1. Hold the part 1 in bench vise and cut M6 internal thread in all 4 holes. Clean the threads without burrs. Finish file on all the parts and deburr in all the corners of the jobs. Assemble all the parts as shown in the job drawing.
Let's have a recap of what we have learned today. We have learned to mark dimensions with vernier height gauge, file part 1, 2, 3, 4 to size, drill, ream and tap at correct location, counter bore to the required depth, assemble part 1, 2, 3, 4 with dowel pins and cheese head screws. Thus, we have learnt about assembling keys and dowel pins. Hope you have a clear understanding on this. Do this exercise with the help of your instructor. Filing and fitting an angular mating surface is a process used to ensure that the mating surfaces fit together perfectly. It involves using a file to remove material from the surface and then fitting the surfaces together to ensure a tight and accurate fit. In this video, we will be seeing about file and fit angular mating surface within an accuracy of plus or minus 0.02 mm and 10 minutes angular fitting. Come, let's go into the video.
At the end of this demonstration, you will be able to mark angular outlines of part 1, 2, 3 with an accuracy of plus or minus 10 accuracy. File part 1, 2 and 3 maintaining the accuracy of plus or minus 0.02 for fitting. Assemble the part 1, 2 and 3. Finish and deburr. Tools required. Steel rule 300 mm. A steel rule is a measuring instrument that is used to take accurate measurements of the length, width and thickness of various components. Scriber. A scriber is a marking tool that is used to make accurate lines on metal surfaces. Punch. A punch is a marking tool that is used to create indentations and other markings on metal surfaces. Ball-peen hammer. A ball-peen hammer is used to shape and form metal components such as by bending or flattening a piece of metal or by shaping it into a specific form or contour. Hacksaw frame with blade. A hacksaw frame is used along with a blade to cut metals of different sections and is specified by the type and maximum length of the blade that can be fixed. Smooth file, flat, square, triangle. A smooth file is a type of file that has a cutting surface that is much finer than rough or bastard files. It is used for fine shaping, smoothing, and finishing work on metal components after initial roughing out work has been done with coarser files. Flat files are typically used for removing material quickly and efficiently, creating flat or angled surfaces, and shaping or smoothing curves or edges. The triangular shape of the file makes it ideal for reaching into tight corners and removing material from hard-to-reach areas. Triangle files are available in a variety of sizes and cuts, which determine the courses of the teeth on the file. Tri-square. A tri-square is a measuring tool used in metalworking to check the accuracy of right angles and to mark straight lines. It is a simple but essential tool for anyone working with metal or other materials. Equipment required. Surface plate or table. Surface plates are used to measure the flatness and precision of other components such as machine parts, tools, and fixtures. They are also used for layout and inspection work where precision and accuracy are critical. Vernier height gauge. A vernier height gauge, also known as a height gauge or a height caliper, is a precision measuring instrument used in metalworking and mechanical engineering to measure the height of objects, and also it's used to make precise marking on the jobs. Angle plate. An angle plate is a work-holding device used in metalworking and machining that is designed to hold and support workpieces at a precise angle to perform marking function using tools like vernier height gauge. Bench vise. A bench vise is a work-holding device that is mounted on a workbench or table and is used to hold a workpiece firmly in place during machining, cutting, filing, drilling, or other work. Vernier caliper. A vernier caliper is a precision measuring tool used in metalworking and mechanical engineering to measure the internal and external dimensions of objects as well as the depth and step measurements. Vernier bevel protractor. A vernier bevel protractor is a precision measuring tool used to measure angles with a high degree of accuracy. The tool consists of a base, a blade, and a vernier scale. The base is flat and typically made of steel, while the blade is attached to the base and can be rotated to measure angles. Before starting job, there are some preliminary checks to be made. These are as follows. The first check to be made is raw material check. Check the raw materials for its size. Next, we are going to file all the parts. File the surface to its overall sizes for flatness and squareness. Next, we are going to mark the dimension for making holes in all the parts. Mark the dimension and location as per drawing on part 1 by using vernier bevel protractor. Mark the dimension and location as per drawing on part 2 by using vernier bevel protractor. Mark the dimension and location as per drawing on part 3 by using vernier bevel protractor. Now, we are going to punch witness marks in all the parts. Punch on the location of marked lines on part 1 using center punch. Punch on the location of marked lines on part 2 using center punch. Punch on the location of marked lines on part 3 using center punch. Remove excess materials by hacksawing. File the parts to its size and shape. File to size and shape in part 1, maintaining an accuracy plus or minus 0.02 mm and angular of 10 minutes. File to size and shape in part 2, maintaining an accuracy plus or minus 0.02 mm and angular of 10 minutes. File to size and shape in part 3, maintaining an accuracy plus or minus 0.02 mm and angular of 10 minutes. Now, let's begin the process. Check the linear dimensions with vernier caliper and angular by vernier bevel protractor. Fit part 1, 2 and 3 simultaneously and finish. Apply little oil for preservation and evaluation. Note: do not mark angular dimension or angle by scale or set square while marking. Do not make a force fit.
Let's have a recap of what we have learned today. We have learned to mark angular outlines of part 1, 2, 3 within an accuracy of 10 minutes. File part 1, 2, 3 maintaining an accuracy of plus or minus 0.02 mm for fitting. Assemble the part 1, 2 and 3, finish and deburr. Thus, we have learned to file and fit angular mating surface within an accuracy of plus or minus 0.02 mm and 10 minutes angular fitting. Hope you have a clear understanding on this. Do this exercise with the help of your instructor.
Today I am covering my lecture on two topics. My first topic, what is a road structure and cause of deterioration of roads in India, and the second topic is joints in concrete pavements.